Hello everyone, welcome back to the data science program. In this video we'll be covering Python sets. Till now we have covered few data types like Python strings, we have covered Python list, and we have covered Python tuple, and we are left with two data types. The first one is the Python sets, which I will be covering in this video, and in the next video we'll be covering Python dictionary, which is going to be the last data type. So I'll take you guys to the definition part first, where we'll discuss how the Python sets looks like and what is the definition, and then we'll dive into the coding section. So I'll take you guys to the definition part first. So here we have the example of sets, and the definition says that a set in Python programming is an unordered, which means it does not follow order like Python list and a tuple. And if it does not follow order, that means you cannot fetch a particular item from a particular index position, or you cannot do slicing. And it is mutable, which means you can do changes to Python sets. You can use add function, and you have different functions, and that has no duplicate elements, and it does not allow duplicate items. So if you are having 1 2 3 4 and then you have one more 1, if you try to print that set, you will get only one single one. And now I will show you guys three examples. In the first example we have used only integer data type. So here is the example of a set. In sets we have opening and closing curly braces. In a Python list we had opening and closing square bracket, and here we have opening and closing curly braces. Inside that we have used data type integer. All the values are integer. And in the second example we have used the string data type inside set. And in the third example we have used different data types like string, and we have used integer, we have used negative number, and we have it's an example of a heterogeneous set. In heterogeneous you can store different data types, and we have so many data types. We have list, we have tuple, we have dictionary, we have set. So why to use Python sets? So here is the answer to that question. Because sets cannot have multiple occurrence of same element, because it does not allow duplicate items, so it cannot have multiple occurrence of same element. It makes sets highly useful to efficiently remove duplicate values. So it is efficient to remove duplicate values from a list or tuple and perform common math operations like union, intersection, difference. There is symmetric difference as well. So that's about the definition part, and now we will see all the characteristics one by one, and then we will see other topics. I'll take you guys to the coding section now. So I have written the same definition, and why use Python set. I have given the same answer here. In future, if you want to refer this answer, you can fetch it from the description part. I'll be sharing this code in the description part. And we have covered this part, and now we will see the characteristics. So it has mainly 4 characteristics. The first one is the mutable. It is mutable, you can do changes. The second one is unordered, it does not follow any order. The third one says it cannot contain mutable data type, which means set is mutable but it cannot store a mutable item inside set. So 2D sets are not possible, because if in 2D sets you have a set inside sets. So set is mutable, so you cannot store mutable items inside sets. So 2D sets are not possible. And then does not allow duplicate values. So if you have 1 2 3 4 and then you have one more 1, when you try to print that set, you will get only single one. It does not allow duplicate items. So we'll see these examples one by one. First one is the mutable. So we have a function in sometimes I'll be discussing one function, add function. So suppose we have a equals to, and we have this set 1 2 3. We have this set, and there is a function called add. So if you do a dot add, and what add does is it adds single item at a particular time. At one time it adds only single item. So if I add 4 here, and then if I try to print A, so we will get 1 2 3 4. initially we had only 3 items inside this set A, and then after using this add function we are getting 1 2 3 4, which means we have actually added one more items, which means it's mutable, so you can do changes to Python set. The second one is unordered, it does not follow any order. So let's say we have a1 equals to 1 comma 2 comma 3 comma 4, and then we have one more, let's say a2, and in a2 we'll be having same items 1 2 3 4, but on the different index position. So we'll be having on different index position, so we are using the same items but on the different index position. And if a1 is equal to a2 gives us true as the output, that means both are same, which means it does not follow any order, so it is unordered. So what I will do here is I will simply check a1 equals to a2, and if the result comes true, that means it is unordered, it does not follow any order, because indexing it does not follow any indexing. What matters is what are the items present inside that set. So I will simply check whether a1 is equal to a2, we will get true as the output, and this shows Python sets are unordered. And the third one, it cannot contain mutable data types. So what I will do here is I will use 2D set, two-dimensional sets, and I will use one set inside the outer set. So I will take one, okay, I will take the variable b1 equals to, and I'm adding 1 2 3 and 4, and I'm trying to add one more set inside this. So we are adding one more set, let's say 6 comma 7. So we have 2D set, and we already know sets are mutable, so we are trying to add a mutable data types inside set. And if we are getting the output, that means a Python set can contain mutable data type. And if we are getting error, that means it cannot contain mutable data type. So I will simply print b1, and we will get error because we cannot contain Python set cannot contain mutable data type. See, we are getting error here. It's taking a bit of time, but eventually it will run and it will show us the error message. And I will read, by the time it runs, I will show you guys one more example. By the variable b2, see, unhashable type set, which means you cannot use a mutable data type inside b1. And I will in place of this mutable data type, in place of this set, I will use one more mutable data type, which is Python list. I'm using I will simply add 1 comma 2 comma 3, and I will add one more mutable data type, which is a Python list, and I will add 6 comma 7, and I will now try to print b2. We are printing b2, and it will give us the error because you cannot add a mutable data types inside a set. See, we are getting this error symbol. So that shows sets cannot contain mutable data type, so you cannot store a mutable data type inside sets. So we have seen two examples. In the first example, we have used a 2D set, and in the second example, we have used Python list. So the fourth characteristics says that it does not allow duplicate values. I will show you guys one example. C1 equals to, we are taking, I will add few duplicate values, and I will add 1 2 and 3. So we have 1 2 times, we have 2 2 times, and we have 3 2 times. So we have duplicate values inside C1. So if I try to print C1, what will happen is it will remove all the duplicate values, and it will show you the remaining values, which means we will get only 1 2 and 3. We won't get 1 2 times and other number 2 times. So I will simply print, and we will get 1 2 3 as the output because it does not allow duplicate items. And now we will see a few ways of creating sets. We have different ways of creating sets. We have, first we'll be creating empty set, and then we'll be creating 1D and 2D sets, and then we will see homogeneous sets, heterogeneous, and by using the type conversion. So we have these many ways of creating a set. So first we will see empty set. So till now we have covered list and tuple, and if you go by that, if we go by that logic, what people think, like if you have to create a empty set, this is going to be the syntax for that. And now if you try to print, let's say D, we will get the empty set here. But if you try to check the data type of this D, it will show you as the dictionary part. We will get the dictionary as the output here. I will add one more code section here. What I will do is I will add one more section, and I will show you guys the data type of this D. I will simply check print and then type of this D, and we will get dictionary as the output, which means it's not a set, it's actually a empty dictionary. So by default Python has given this syntax to dictionary and not to set. So this is not the correct way of creating empty set. So I'll tell you, I'll show you guys the correct way how to create an empty set. I will add one more code section, and I will add a comment here. Wrong syntax. This is the wrong syntax, and I will show you guys the correct way. What you have to do is you have to simply write set, and you have to use this opening and closing bracket. And now if you try to print, this D1, we will get the output as an empty set here. See, we are getting this set. And if you try to check the type of this set, type of this D1, we will get as set. So I will simply check print, and then inside print type of D1, and again I will run, and see, we are getting class set. Now we have created the empty set. This is the correct way, and I will write a comment here, correct way, correct syntax, and now we'll see 2D. I've already showed you guys 2D sets are not possible, because set is already a mutable data type, and in set you cannot store mutable data types inside a set. So I will show you guys. I will create one set, and I'm storing 1, 2, 3 and 4, and I'm storing one more set inside this. I'm storing one more set, and I'm storing 6, 7, and now I will print. Now I will print C1. And it will show you guys the error, because we are trying to store mutable data types, which is not possible. So 2D sets are not possible. I will write a comment. See, unhashable type set, which means you cannot create. Oh, actually this is the example of 2D sets. Sorry, this is the example of 2D sets. So I have written it in 1D. So what I will do is I just simply copy this, and I will paste it over here in 2D part. 2D sets are not possible. So in 2D part I will simply paste, and now if I run, we will get the error here, because 2D sets are not possible. And in one-dimensional sets I have to simply remove this part. I will simply remove this part. It's taking a bit of time, so in 1D sets is simple. I'm typing D2, and we are using 1, 2, 3 and let's say 6, and you can store different data types. True, if you are using true inside a set, it will give you the value as 1, and we have already 1 here, so it will show you only single one. Now if I print d2, so because true value is taken as 1 and we have already 1 here, so we will get only single one. And I don't know why it's taking time, but Google Colab sometimes take a lot of time, but can't help it. I will now print this. It's an example of a 1D set. In place of this true, you can use false, and then if you use false, we will get false as the output. True is taken as 1, that's why we are not getting the output. And now if you use false instead of this true, we will get false as the output. See, we are getting this false here. So we have created 1D, we have created 2D, and now we will see homogeneous. In homogeneous, we will be using same data types. So if you are using an integer, we will be using all the integers. If you are using string, we will be using all the strings. So I will create one set 2, 3 and 4, 5. What I will do is I will simply copy this because I have to use this several times. So I'll simply copy this, and I will print E1. I will print E1, and we will get the output as 1, 2, 3, 4, 5. And now I will show you guys the example of a heterogeneous type. Heterogeneous. Inside heterogeneous, you can. I will simply paste. And okay, heterogeneous example is going to be different. We'll say we have E2, and inside that we have an integer, we have a string, here, we have a float, and then we have a complex number 5.06 plus. Okay, and now I will print E2. I will print E2, and we will get the output as 1, this string 5.0 and 6. We are getting this output. So it's an example of a heterogeneous sets. And there is one more way. By using the type conversion, we can create Python set. So let's say we have E4 equals to, and we are converting it to sets. So we'll be using set, and inside this set, suppose we are using this 1, 2, 3, we are using this list, and we want to convert this list to set. So that's the syntax for converting a data type to set. We can convert a tuple to set. If for that we have to use round braces, and I will simply print E4, and we will get the output as a set. We will be getting the output as a set. We are getting set here. We have given the input as a Python list, and we are getting the output as a set. And now we will see accessing item. Accessing item is not possible because set does not follow any order. So still I will show you guys one example. Let's say we have this example. And because it does not follow any order, we don't know at what index position this 1 is present, at what index position this 3 is present. So we cannot, if you try to fetch this by using the indexing, so suppose if you go by the list logic, this is present on the first index position. So if you try to print E1 of first index position, and now if you try to run the cell, we will get the error here because it does not follow any indexing. So if it does not follow any indexing, you cannot fetch an item from a particular index position. So see, set object is not subscriptable, so you cannot do, it's not possible. And because accessing item is not possible, editing is also not possible, because if for editing part also you need indexing. If you don't know the index position, you cannot edit the particular item. I'll show you guys the example first. Suppose we have the same example here, and suppose we want to edit this, we want to convert this to 10, let's say. So what we have to do, e1 of first index position and then equals to, let's say, 10, and now we will try to print e1. If you try to print e1, because it does not follow any indexing, you won't be able to see the output. Eventually we will get the error only here. See, we are getting the error sign here, and if you see the message, it will show you that it's not possible because it does not follow any indexing. See, set object does not support item assignment, because item assignment means you cannot edit because it does not follow any order. And for adding item is possible, just like in list we have extend append, here we have add and update. What add does is it adds a particular item to, it adds only single item at one time, and if you want to add multiple items, for that we'll be using update. So what I will do is I will simply use this set, and I will try to add one more item, which is going to be 6. So what I am doing, you simply have to wait and you will get all these functions here. So I will simply use add function, and I'm adding this value to this set. I'm trying to add this 6 in this even set, and then I will simply print. I'm printing e1, and now if you see the result, we'll be having 6 inside this set. We'll be having 6, so we'll have 1 2 3 1, and as you can see, we are getting this 6. So we are using this add to add a particular item. We will be adding only single item. If you have to add a single item, we'll be using this add function, and if you have to add multiple items, for that we'll be using the update function. So I'll use the same example here, and I will simply do e1 dot and update, and inside that you have to send a list. Inside list you have to add multiple items, so we are adding multiple items, 7 8 and 9. We are adding these multiple items inside e1 set, and now if you try to print e1, you will get all these values inside this set. For deleting also, we have a few functions. Deleting a particular item is not possible because it does not follow any indexing. So what you can do is you can simply delete the complete set. I will simply paste, and I will show you guys, if you are trying to delete a particular item from a particular index position, that's not possible. So what I'm doing is I'm simply trying to delete, okay, del of e1 of, let's say we are trying to delete this 2. So it's present, by going by the list logic, it's present on the first index position, but actually it's not. So now if I, okay, simply I will simply check this. I will simply run, and I will check whether this operation is happening or not. So it's not happening because you cannot delete a particular item from a particular index position. So what we can do is we can simply delete the complete set. I will see set object does not support item deletion. So item deletion is not possible, but deleting the complete set is possible. So I will add one more code section. I will add one more cell here. It's taking a bit of time. So Google Colab, sometimes it takes a lot of time, but can't help it because it gives you this flexibility. Google Colab is really smooth. Sometimes if internet connection is weak, it takes a lot of time. I will try to add this cell again. I don't know why it's taking too much. I'm getting this option here. Okay. I don't know why it's taking too much time. taking too much of, I don't know. By the time this cell is running, I will show you guys this example, the clear example. So what clear does is it basically deletes all the items from a set. It does not delete the complete set, but it deletes the item present inside set. So I will paste and I will simply use e1 dot clear. If you do e1 dot clear and e1 dot clear, and then if you try to print e1, we will get an empty set because all the items are already deleted inside e1. So print e1, and we will get the output as the empty set here. We will get the output as the empty set, and see, we are getting the empty set here. And now I will come back to this problem. Deleting a particular item is not possible, but still we can delete the complete set. Let's say we have e5 equals to 1 comma 2 comma 3 comma 4, and I will print e5 first. I will print e5 first, and I will show you guys we will be getting the output. And after deleting, I will try to print e5. See, we are getting this. And now if I delete the complete set e5, and after that if I try to print e5, then it's not possible because there is no e5, there is no set like e5, because we have already deleted e5. So staying time, but eventually we'll get the error because e5 is not present. There is no e5 only. So I'll come back to this. We have covered this clear, and what pop does is pop basically it removes a random value. It deletes a random value from a random position. So let's say we have this set. Okay, don't know why Google Colab is misbehaving, but still I will try to add. Okay, I will simply add e6. Let's say we have e6, and we have 1 comma 2 comma 3 comma 4 comma, let's say we have these many items. And if what I will do is I will simply pop e6 dot pop, e6 dot pop. If you use it, will randomly delete any item. So if you simply run, it will show you which items it's actually deleting. It has deleted one. And now if you try to print e6, there won't be any one. We have only 2, 3 and 4, so it deletes a random item. And then we have discard and remove. Both are almost similar, discard and remove. But if you try to discard any items which is not present, it won't show you the error message. But in remove, if you try to remove any item which is not present, it will show you the error. So I will show you guys 2 examples here. So first I will create one set here. So suppose we have e7. And inside this e7 we have these many items, 1 2 3 4, and then we have one more item. So I will simply use e7 dot discard. If you do discard, and suppose we are discarding this third item, and then we are trying to print, then we are printing e7, so we will get the output. Inside that output we'll be having 1 2 and printing e7 tuple object has no attribute discard. Okay, I have to use I've used this tuple symbol. Actually we have to use this set symbol. And now if you try to run the cell, we'll get the output. And inside that output we don't have 3 because we have already discarded. But if you try to discard a particular item which is not present inside this E7, let's say we have so let's say I am let's say I'm trying to I'm discarding this E7 dot discard. I'm discarding let's say 100, which is not present inside E7, and then I'm trying to print E7. I'm trying to print E7. We will get the output, but it won't show us the error. See, it has discarded 3, and whatever result we are left with, we have got that. But we did not have had this 100 inside E7, but still it did not show us the error message. But same thing if you try to do in this remove part. Same thing if you try to do. So let's say we have E8 equals to, suppose we have these many items, and what I'm doing is I'm doing E8 dot discard, E8 dot remove. So I'm removing this 5, let's say I'm removing this 5, and I'm printing E8. I'm printing E8, and we will get the output as 1 to 6. We will be getting the output as. But after that, if we try to remove 100, which is not present inside this E8, then it will show us the error message. See, we are getting the output same as discard, but the difference is if we try to remove a particular if we try to remove an item which is not present inside this, it will show us the error message. So I'll add one more cell. I will add one more cell here, and what I will do is E8 dot discard. Okay, E8 dot remove, and I'm removing let's say 100, and then I'm printing E8. I'm printing E8. Printing E8. So I'm printing E8, and it will show us the error message here. See, we will get the error message here because whenever you're using the remove function, you cannot remove an item which is not present inside the set. So that's the difference between remove and discard. And with that, we have covered the deletion part, and after that now we will cover the operations on set. So we have already covered this in our school times, these operations. So still I will show you guys these examples. So what union means is, so let's say we have, for union we have this symbol, for intersection we have this symbol, and for difference and for symmetry difference we have these symbol. So what I will do is I will simply add two sets. Let's say F1 equals to, I'm using these many items, and I'm using one more set. And inside that set I'm having 5, 6, 7, 8, 9. I'm having these many items. So what union does is it prints all the items single time. It does not print duplicate items. So I will simply print I will simply do F1 union F2, and it will print all the items single time present inside F1 and F2. So 1, 2, 3, 4. So here we have 5, here also we have 5, but we have printed 5 only single time. So all the items will be printed single time. So then we have intersection part. Intersection part will print all the items which are common in both the sets. So I will simply copy this. Don't have to copy. I will simply use F1, and I will use and. This is the symbol for intersection, and I will do F2, and we will get all the common items, which is 5 and 6 here. So we will get 5 and 6 as the output, because only these two items are common in both the sets. So it's taking time, but see, we are getting the output 5, 6. Then we will see difference. So what difference in difference, what happens is, suppose we are using F1 first minus F2. So that means it will print all the items of F1 which is not present in F2. which is not present in F2. So if I show, so what are the items of F1 which is not present in F2? So we have 1, 2, 3 and 4. See, 1, 2, 3, 4. Apart from that, 5 and 6 is already present in F2. So we can do F2 minus F1 as well. I will show you guys this. I will show you guys that example, F2 minus F1. So we have F2 minus F1, and what it means is all the items of F2 which is not present in F1. So see, in F2 we have 7, 8 and 9 which is not present in F1. So, and then we have symmetric difference. Symmetric difference means it will remove all the common items, and apart from that common item it will print all the items. So we have F1 and then we have F2, and it will remove the common items, so which is 5 and 6. Apart from 5 and 6 it will print all the items. Then we have a membership operator, in and not in. We have already studied in and not in list and tuple. So first we will see in. Okay, I will simply copy this. I will copy this example, F1. I will copy this and I will paste it over here. I will simply paste, and then we will check whether 1 is present inside this F1. So 1 in F1, we will get true as the output because 1 is present inside F1. You can check the other example. I will show. I don't know why Google Colab is taking too much time. We will see whether 8 is present inside this F1. So we will check 8 in F1. 8 in F1. 8 in F1, we will get false as the output. Similarly, we have not in to check whether a particular item is present which is not present inside that set. So 8 in F1, it's because 8 is not present inside F1, we are getting false as the output. Then we have not in. And simply paste, and 1 not in F1, we will get false as the output. And then we have loops. You can iterate. So we have this set for I in F1. For I in F1, we will print I, and we will get 1 to 6 as the output. See, we are getting. So you can iterate on sets. Then we have a few sets functions, and these are len, min, max, sum, sorted. We can use union, update, intersection as the function. So we'll see these examples one by one. So first, what len does is it basically tells you the length of the set. So taking the same example, what we have to do is we have to simply print len of F1. Len of F1, if you do, we will get the length of F1 directly, and we will get 6 as the output. We will get 6 because the length of the set is 6. 1, 2, 3, 4, 5, 6. Then we have minimum, and print min of F1. We will get 1 as the output because 1 is the minimum here. Then we have max. We are getting 1 as the output. Print max of F1 will give us 6 as the output. Printing a max of F1 will give us 6 as the output. As you can see, 6 has the maximum value. We are getting 6. Then we have sum. We will print sum of F1. Okay, sum of F1, and then we have to close, and we will get, if you add all these items, we will get the output as 21. 1 plus 2 3 6 10 15 and 21. We are getting 21. So we have sorted operation. Sorted, what it does is it basically arranges the sets values in ascending order. So I will simply print f1 of so print sorted of f1, sorted of f1, and you can simply print, it will arrange all these values in ascending order, and we will get the output inside a Python list. You can reverse this order by using reverse equals to true. So I will add one more cell here, and what we can do is you can reverse this order. So I will simply print sorted of f1, and I will use reverse equals to false as the parameter. Reverse equals to false as the parameter, and then if you try to run the cell, this order will be reversed. So we are getting the reverse order. We are getting the output in the reverse order here. Then we have union. We have already covered this operations on under operation. We had union, intersection. Inside functions also we have inside. I don't know why it's taking time, but we have to wait for a few seconds. By the time we get see, inside functions also we have union. So it will give us the same output. How to use? So I will create two sets, 1, 2, 3, 4, 5, 6, and then I will create one more g2 equals to let's say 5, 6, 7, 8, 9. So inside function, this union function also we can use g1 dot, we have to use union. So if you wait for some time, eventually you will get the union option, but you can type it by yourself, and you have to simply provide g2. And now if you run the cell, we will get the union. All these values will be printed single time. See, we are getting these values single time. What update does is update. You can add a particular item. Suppose we have g1 dot update, and I'm updating g2. I'm updating g1, and I'm simply now I'm printing g1, and then I'm printing g2. So what this syntax means is, we are whatever updated value we are getting, that updated value will be stored inside g1, and g2 will remain as it is. So in g2 we have these values. These values will remain as it is. So I will show you guys after running what output we are getting. See, what this is union update. So we are getting the union values. So first item, whichever the item which you are using in the first position, here we are doing the intersection update. So intersection update will be updated in the first value, which is g1, and g2 will remain as it is. And then we have intersection. I will simply copy this g1 and g2. Copy. I will paste it over here. Google Colab, sometimes you cannot deal with Google Colab, but still you have to. I will simply paste. Oh, I'm getting f1 only, so I will use f2. Let's say we have 5, 6, 7, and we have these many items. So intersection, simply what I can do is I can simply g1 and g2 I already have, so I can use g1, and I can simply use g1 and g2, and we will get all the common item as the output. see we are getting 5 6 in G1 and G2. If you see, where is G1 and G2? We have G1 and G2 here. We have, I don't know, I think I've written it somewhere. Where I've written G1 and G2, I've written it somewhere. So G1 and G2, we have these many items common. So what I will do is intersection update. I will create new sets. H1 equals to 1, 2, 3, 4, 5, 6, and then we have H2, and inside H2 we have 5, 6, 7, 9. So we have these many items. So intersection also we can use intersection update. So whatever the value of intersection update, that will be, so suppose we are using H1 in the first place and dot intersection, we will wait for some time, and eventually we will get that function. See, intersection update we are getting. In intersection update we are giving H2. So whatever we are doing this operation value will go into H1 and H2 will remain as it is. So now I will print H1 and H2, print H1, and then I will print H2, and then you can check the result. See, we are getting the result. This intersection value is we have got in H1, and H2 has remained as it is. And similarly we have difference, so I will use H1 minus H2, and we will get all these items of H1 which is not present in H2. So 1 2 3 4 we will get. Okay, I have to first write, to simply copy this first, and I will paste it over here, paste, and then I will paste this value, and I will and then I will use H1 minus H2, and now we will get all these items of H1 which is not present in H2. So 1 2 3 4 we will get 1 2 3 4 as the output. We will get 1 2 3 4 as the output. Similarly we have H1 difference update. So in difference update I will do H1 dot, and I will wait for some times. Difference update, and inside that I am giving H2. So H2 will remain as it is. What instead of this syntax we can use H2 and we can use H1 here. So if you use H1 here, H1, the value of H1 will remain as it is, and whatever this difference output we are getting, that will be stored inside H2. So then I will print H1, and H1 will remain as it is, and the operation value will be reflected inside this H2. And now just wait for some time and we will get the output. See, H1 we have got the result. H1 has remained as it is, and inside this difference, the difference between these two, that result we have got it in H2. So then we have symmetric difference. So symmetric difference, I have to copy this again, and I will simply paste. Okay, I will copy this again. Just wait for few minutes and wait for few seconds, and we are done. Then we have H2. And we will do H1 symmetric difference H2. So it will remove all the common items, and apart from that it will show all the output. So 5 and 6 is common between these two, so apart from that we are getting all the output. And then we have symmetric difference update. So suppose we are doing H1 dot, I will wait for some times, and symmetric difference I update, and I will give h2, and then I will print h1, and then I will print h2. So h2 will remain as it is, and that operation value will go inside this h1. See, in h1 we have got the operation value, symmetric difference operation value, we have got it in h1, and h2 has remained as it is. And then we have is disjoint. So suppose we have two sets and there is no common items between these two sets, so that will be considered as a disjoint set. I will show you guys one example. Let's say we have j1 equals to 1 2 3, and similarly we have one more j2, and inside that we have all the different items, so 4 5 6. So we don't have any common items present between these two, so this is considered as a disjoint set. So if I do j1 dot is disjoint, and just wait for some time, and is disjoint, and I will provide j2, and then we will get true as the output, because there is no common item between these two. We will get true as the output. See, we are getting true. And suppose if we would have used 1 here instead of this 4, then this j1 dot is disjoint would have given us false as the output. Similarly, we have subset. So just wait for a few seconds. Okay, don't know why Google collab. Yeah, so now I will take k1 equals to 1 2 3 4 5 6, and we have k2 equals to, let's say 2 3 4. So in k2 we have 2 3 4, and all these items are already present inside k1. So this k2 is a subset of k1, and this k1 is the superset of k2. So if we check k2 dot is disjoint, if you do is disjoint, and if you provide k1, we will get true as the output, because k2 is the subset of k1, See, false. Okay, we have to use k1 here. If you use k1 and if you use k2 here, then we will get true as the output. k1 is disjoint k2. Okay, sorry, actually what I have to use is subset. Actually I have used correct syntax only. K1 is subset, and if I will change this to k2 only and this to k1, so k2 is a subset of k1, which is true, and now if I print, we will get true as the output. See, we are getting true. Similarly, if you do k1 dot is subset of k2, we will get false as the output. Similarly, we have superset. So here k1 is the superset of, I will simply write here, k1 superset of k2, and k2 subset of k1. So then we have superset. Similarly, we have superset. If you do, we already know k1 is this k1 is the superset of k2. So if you do k1 dot is super, just wait for some time and we will get is superset option. Is superset, okay, is superset, yeah, we are getting is superset here. So we are getting is superset here, is superset, and then to provide k2, and then we will get true as the output, because k1 is the superset of k2. k1 is the superset, we are getting true as the output. And then we have copy. Let's say we have L. L equals to, let's say we have 1, 2, 3, 4 and 5. What we can do is we can create a shallow copy of this L and we can store it inside M. So we can store M equals to L dot copy. So we are creating a shallow copy of L. It's not there is a difference between deep copy and shallow copy, but as of now you just for the understanding, you just understand, okay, we are creating a copy of L and we are storing inside M. So what I will do is I will now print L first and then I will print M, and then I will print ID of L, print ID of L, and then I will print ID of M, and then I will run the cell, and then I will run the cell. See, we will have all these values of L inside M because we have created a copy of L and we have stored it in M, but the index position of these two sets are different. As you can see, 3, 4, 4, and here we are having 9, 4, 4. So both the sets are stored in different index position. So then we have another set called frozen set, and frozen sets works similar to a set. The only difference is frozen set is just an immutable version of Python sets, which means Python set is mutable whereas a frozen set is immutable. While elements of a set can be modified at any time, elements of frozen sets remain the same after creation. Due to this, frozen sets can be used by keys in dictionary or elements of another set. So I will show you guys how to create a set. Just remember one thing, frozen sets is similar to a set, only difference is frozen sets is immutable. So, and till now we have studied that 2D sets are not possible because you cannot store a mutable data type inside a set. But if because frozen sets are immutable, you can store frozen sets inside sets because it's immutable. So I will create frozen set. Let's say n equals to, and this is the syntax, you have to type frozen, and we are getting this frozen set, and inside this you have to provide any list or tuple you can provide. And now if you print n, we will get the output as a frozen set. We will get a frozen set as the example. I will show you can perform all these operations on frozen, all the operations which are possible in sets. You can perform all these operations in frozen sets as well. I'll show you guys the example. Like union operation, intersection operation, all these operations you can perform. So what I will do is I will create set. Let's say we have this frozen set. I will simply copy and I will paste it over here, and I will create one more. Let's say we have one more cube, and I'm typing frozen set. Frozen set, you can use frozen and just wait for some time. Frozen set, and I'm creating one more frozen set, and I'm storing these values like 5, 6. I'm storing 4. Okay, I'm using let's say 4, 5, 6 and 7, and you can perform all these operations which we have already studied for sets. So what I will do is I will use union operation on n with q, and if I run the cell, we will get this union between these two frozen sets. Just wait for some time. See, we are getting, and that output we are getting inside a frozen set only, but we are getting the union. See, we have used 4 2 times, but we are getting only 1 time, because in union we get the output only a single, we get the output for only once. We don't get the duplicate values. And then we have 2D frozen sets. So I have already told you guys 2D frozen sets are possible because frozen sets are immutable. So what I will do is I will create r equals to, I'm frozen set, frozen, I will wait for some time and I will get the frozen set, and I'm creating, you can use a tuple inside frozen set 3, and what I will do is I will store one more, I will use one more frozen set, I will use one more frozen set inside this. Okay, and inside this I'm using let's say 5,6, and now if we try to print r, it's, we will get the output, we won't get any error because 2D frozen sets are possible. I will simply print r. See, we are getting frozen sets, and we are getting frozen sets inside a frozen set, so we are getting these as output. And then we have our last topic, list sets comprehension. Similar to list comprehensions, in list we use opening and closing square bracket, inside that we give our expression and iterable, we use our iterable. So sets comprehension is the method for creating sets in Python using the elements from the iterable, like list, sets, tuple. Just like we use list comprehension to create list, we can use set comprehension instead of for loop to create new sets and element to it. So I'll directly show you guys the example. In list we have used this syntax, and we have used I for I in range like this, but here we are using sets, so we will be using the curly braces, and we'll be using our expression. Suppose we are printing the square between 1 to 10. So what I will use, I'll be using I, and then I will be using square for I in range, and I'll be using this range from 1 to 11, which means I'll be printing the square between 1 to 10. From 1 to 10 I'll be printing the square, and if I run the cell, we will get the square from 1 to 10. See, we are getting 1, 2, 3, 4, 5, we are getting the squares. You can add items, so I will show you guys one more example. So I for I in range, okay, we are using this range from 1 to, let's say, 25. So we will store these values from 1 to 24 inside a set. See, we are getting the value inside set. Similarly here also we will be storing these values inside a set only. So I will simply print, and we will be getting the output. See, we are getting the output inside a set here. So I will simply reduce the range value. I will reduce the range value to let's say 7, and now we will get the proper output because we were getting the long output. That's why I reduced the range length. You can use other examples as well. So let's say I am printing I square, and then I'm using square of, I'm printing all these squares for I in range 1 to 15, 1 to 12, let's say, and I'm using an if condition. If I is less than 6, so we'll be, what output we'll be getting here, we'll be getting all these squares from 1 to 5. And now if I try to print, we will be getting these squares from 1 to 5. See, we are getting these squares from 1 to 5. So that's about this session. It was a bit long and bit hectic. So we have covered, I don't know why it's showing saving failed since 4 p.m, but I will share this file in the description part. You can fetch it from there. And that's about this session. Thank you for watching this session. Thank you.